Welcome to a lesson with Dr. Powell. Let's take a look at what a function is and define it. What is a function? So a function is a rule, an assignment rule, that takes things in one set, and with that thing, it takes it and it outputs something in another set. So it puts something in and has to take something out. The set that it takes things from is called the domain. At least the category or the set of possible output values, or kind of like the data type, is called the codomain. Not the range, but the codomain. The range is actually the actual outputs that the function has. The codomain is simply gives us the data type of what those values are. So kind of like an over ambient set or environment that this function is allowed to have outputs in is the codomain. A function definition is not complete without stating what the domain is, the codomain is, and a rule for how to take something in the domain. That's what this symbol means. It means X is in D, or X is an element of D. So how to take things in here, and this is an assignment error with a line right here. So X, and it's read as maps to. So that's kind of how we make an assignment. X maps to something in C. So we need a rule for how to make that work. So here's an example. What if we had a function and we defined it as being from real numbers to real numbers? Okay, so we have a domain, we have a codomain, and we have we're going to have a rule for where to take X. So X comes in, what comes out is, let's square it, X squared. So this would be okay, because when you square a real number, you again get a real number. Now, if you were to graph this, notice that, yes, having a codomain just means that we can graph this basically on where the y-axis is going to be real numbers. That's what that means. And so we're kind of visualizing things in here. However, the domain is just from 0 upward, but the codomain is all possible. Is the set of values that we're allowing this function to take on, so that this function can still be called well-defined. If, however, I take a function like g that goes from R to R, so this is domain and that's codomain, and I define it as the square root of X, this is no longer well-defined. That is because this symbol and this rule doesn't always output real numbers. So this data type is wrong. So if you were programming and you're listing out what kind of data type to assign to your variable, your function wouldn't work if your output variable was assigned as a real number. Now, and for instance, if we plugged in something like negative pi into G, we're attempting to do this, which, and if we're only looking for real number outputs, we're going to get an error. That's not going to work. However, if we redefined our function G in a different way, what if we made the codomain not R for real numbers, but C for complex numbers? Numbers like a plus bi, where I is the square root of -1. Well, in that case, this would work, because this right here can be thought of, or we can define this in a well-defined way. We can take the following. We can say it's equal to the positive square root of pi multiplied by I. So in that way, we have a well-defined function, and sometimes a function is called a map, because it kind of mapping relationships or mapping things, one thing to another. Kind of all the arrows from an input to an output can be considered like a map, say. And so sometimes a function is called a mapping, hence this word maps to. So this is a well-defined function or a well-defined map from something to something else, from domain to a codomain. And this is the function rule. And this one would work. Another quick example. What if we had a function and let's suppose that we take its domain as z cross z. Now, what does this mean? This means taking ordered pairs. Ordered pairs where 1 is an integer. Z means the set of integers. Integers are whole numbers, positive, negative, or 0. Integers, whole numbers, positive, negative, or 0. So things like -2, -1, 0, 1, 2, etc. So these are the things that make up Z. And Z cross Z simply means ordered pairs. So so if this is our domain, then that means we're plugging in to our function or our process two different, or an ordered pair of two different things. That's the thing that's coming into the function. That's the input. So suppose we could say 2 and 3. This would be an element of Z cross Z. 2, 3 is an element of Z cross Z. So let's suppose that we take that and let's make a function, or try to make a function. And let's suppose that the domain, or the codomain that is Z. Well, what if we say f of x is equal to, actually, hold on. We need f of x comma y. Why? Because we're inputting ordered pairs. So the input is an ordered pair. Okay, but so the one thing that's coming in is an ordered pair, which has two things in it. So it's like a data structure going into the function. The data structure has two different things. So, but this is the set it's coming from. So 2, 3 is an element of this set. So if we have f of x, y, and let's suppose that we define this as x divided by y. This function is not well defined, does not work. There's a few different reasons why it doesn't work. Reason number one is if you try to plug in 2, 3 into it, you get 2/3. 2/3 is not an element of our proposed data type for output values. So that's not an element. But it is an element of the rational numbers or fractions of integers, quotients of integers, Q. So Q means fractions of integers, an integer here and an integer here. And that would, now if we change the codomain to Q, does it work? Well, almost, not quite. There's another problem. The other problem is, what if we try to plug in f of 1 over 0, or f of 1 comma 0, we would get 1 over 0, and 1 over 0 is not an element of Q. It's not defined as an element of Q. So that wouldn't work either. Now maybe we could go back and change the domain to make it work. Maybe we could go ahead and say Z cross, maybe we should take away an element. This is set subtraction. Take away, and this is a notation for a list. Take away the element 0 from the second component, Z, the set of integers, and take away an element right there. So this would be a nice domain to use. Then our function would be well defined. And at least given this definition, then it would work. So this was a little description of functions, how to define them, and the parts that make up a good working definition for a function. Thanks for watching.